Hello students, previously lesson 20 form 3 topic 2 we were dealing with direct titration under the aim of determining the known concentration of the analyte. We have done example 5. So today lesson 21 we are going to do example 6 and the question is in the format of chemistry paper 3, KCC chemistry paper 3. So to read the question we are told you are provided with the following: 0.2 molar hydrochloric acid solution labeled solution A. We are also given aqueous sodium hydroxide solution labeled solution B. We are also given phenolphthalein indicator. So we are told the aim of the experiment or the titration is you are required to determine the concentration of solution B in moles per liter. Remember, in direct titration we were having two solutions. One solution was known as a standard solution, and a standard solution is a solution whose concentration is known. In our case, hydrochloric acid is the standard solution because we know the concentration of hydrochloric acid. We were having another solution called the analyte. In our case, the analyte is sodium hydroxide because we don't have its concentration. So the aim of the experiment or the titration is you are required to determine the concentration of solution B in moles per liter. Or during the exam you can be told you are required to standardize solution B using solution A. That will be the way they can be told during the exam. So to go to the procedure, the first procedure, we are told using a bipette and a bipette filler, place 25 centimeter cube of solution B into a 250 ml volumetric flask, full stop, add 150 centimeter cube of distilled water, shake well and top up to the mark, then label this solution C. Using a bipette and a bipette filler, place 25 centimeter cube of solution C into a 250 ml conical flask, add 2 drops of phenolphthalein indicator, titrate solution A with solution C. Then we are told record your results in the table below. We are given the titration table here. So the final burette reading, the initial burette reading, volume of solution A used in centimeter cube is given. So the first question, we are told but A, determine from here 1 the average volume of solution A used. So to calculate the average volume of solution A, we have to check our titrants. We have done 3 titration and check the titrants whether they are in the range of plus or within the range of plus or minus 0.2. So here we are having 15.0 and 15.1. So they are in the range of plus or minus 0.1. Here is 15.1 and here is 15.1. So in the range of 0.00 here. Then 15.0 with 15.1, they are in the range of plus or minus 0.1. So that means all the 3 titrants are in the range of plus or minus 0.2. So we can add all of them, then we get their average. So we are going to have 15.0 plus 15.1 plus 15.1, then divided by, we have done 3 titration, so we have to divide by 3 to get the average. So here, using the calculator, we are going to get 15.0666. So we are going to have 0.7 to round off. So the unit is centimeter cube, and that is our first answer. To go next. But Romeo 2, we are told the number of moles of hydrochloric acid solution A used. So if I want to get the number of moles of hydrochloric acid, what is the formula for calculating moles? We can use the formulas molarity times volume used over 1000. This is the formula for calculating number of moles. So what is our molarity? The molarity of hydrochloric acid. We are given 0.2 mole. We said hydrochloric acid is our standard solution. So we are going to have 0.2 multiplied by, what is the volume used of hydrochloric acid? We can check again. We are having here volume of solution A used, and solution A in our case was hydrochloric acid. 0.2 molar hydrochloric acid labeled solution A. So what have we gotten about the volume of solution A used? Here, the average volume of solution A used, we are having 15.07. So our volume used is 15.07 divided by the 1000, which was in the formula. So, using the calculator, what are we going to get as our number of moles? So we are going to get 0.003014 moles of hydrochloric acid. This will be our number of moles of solution A or hydrochloric acid used. So problem 3, the number of moles of sodium hydroxide in 25 centimeter cube of solution C. Remember, this 25 centimeter cube of solution C has reacted with the hydrochloric acid, that 15.07 hydrochloric acid, which it is number of moles we have gotten right now. So that means if we write the question for the reaction between hydrochloric acid and sodium hydroxide, we can use the number of moles of sodium hydroxide in 25 centimeter cube of solution C using mole ratio. So let's start by writing the equation. So we're having sodium hydroxide aqueous plus hydrochloric acid aqueous. We are going to get sodium chloride aqueous plus water. Remember, this equation is self-balanced. So to see now the mole ratio between sodium hydroxide ratio hydrochloric acid, it is 1:1. So we have gotten the number of moles of hydrochloric acid as 0.003014 moles. So what about the number of moles of sodium hydroxide? We can cross multiply. There we are going to get 1 times 0.003014 divided by 1. Here we are going to get 0.003014 moles of sodium hydroxide. That will be the number of moles. Okay, next we are told by Romeo 4 the number of moles of sodium hydroxide contained in 250 centimeter cube of solution C. So here we are having the number of moles of sodium hydroxide in 25 centimeter cube of solution C. So we can say if 25 centimeter cube of solution C can give us a number of moles of 0.003014 moles, we can say, what about 250 centimeter cube of solution C? What will be the number of moles that is going to give us? So we are going to have 250 multiplied by 0.003014, then divided by 25. So here, what are we going to get? Here, we are going to get 0.0314 moles. That will be the number of moles. Then lastly, we are dealing with the part B of the question. But P, we are told the concentration, determine the concentration. We are having determine the concentration of solution B in moles per liter. That means they're asking us about the molarity of solution B. And if you remember, we have not been given any information about solution B, that's the sodium hydroxide. But here, they have given us using a bibate, and a bibate filler, place 25 centimeter cube of solution B. So this 25 centimeter cube of solution B has been diluted to 250 centimeter cube of solution, and it has been labeled as solution C. So if you want to get the molarity of this solution C or sodium hydroxide, we have to take the number of moles of solution C in 250 centimeter cube of solution as our number of moles. Then we multiply by 1000 and divide by the volume of the sodium hydroxide, that's solution B, which was 25. So that means we are going to say concentration of solution B in moles per liter, which we can say molarity. Molarity will be equal to moles multiplied by 1000 over volume used. Volume used, that's our formula. So that means what will be our moles? The moles of sodium hydroxide will be 0.0314 multiplied by 1000 and divided by the volume used, which is 25, which was in the bibate. So this, we are going to get 1.256 mole, 256 moles per liter. which we can write as 1.256 mole, which is M capital letter. That will be the end of our lesson.